In our solving today, we look at conservation of momentum. For more than 7 years of my teaching, Cambridge A levels, some students have issues with collision that comes with ankle. Today, if you are one of them that has issue, sit tight as I take you through step by step on how to answer these questions and get all the marks. There are some places I will show you where you shouldn't make mistake. These are the common places students make mistake and miss their mark. Let's start with the law of conservation of momentum. The law of conservation of momentum states that in an isolated system, the sum of momentum before collision is equal to the sum of momentum after collision. The key words there are isolated system. This and the sum of momentum before collision equal sum of momentum after collision. Those are the places they will give you 2 marks. Next question. Two particles A and B collide elastically as illustrated in figure 5.1. A has 500 meter per second and B is at rest. They collide and A has angle of 60 degree while B has angle of 30 degree after collision. The statement says the initial velocity of A is 500 meter per second in the x direction and B is at rest. The velocity of A after the collision VA at 60 degree to the x direction. The velocity of B after collision, the collision is VB at 30 degree to the x direction. The mass m of each particle is 1.67 times 10 to the power of minus 27 kilogram. Explain what is meant by the particles colliding elastically. What is meant by the particle colliding elastically is the kinetic energy before collision is equal to the kinetic energy after collision. The next question, BII. Calculate the total initial momentum of A and B. The law of momentum that we stated says MUA plus MUB. That is for the initial momentum. Our UB is 0 and our M, so we are going to use 1.67 times 10 to the power of minus 27 times 500. The answer is 8.35 times 10 raised to the power of minus 25. Question III. State an expression in terms of MVA and VB for the total momentum of A and B after the collision in the x direction. X direction means in the horizontal direction. Let's get to the question. Let me make a few explanations that helps you to get this right. Whenever we have collision with angles, we consider all the quadrants. And take note of this. First quadrant, all angles are positive. Second quadrant, only sine is positive. Third quadrant, only tan. And fourth quadrant, only cos. In this collision, we see it said that for cos and sine, this will give us positive. Here, for cos, it will give us positive, while sine will give us negative. The second thing I want you to notice that initial momentum, the movement of this is only horizontal, so it has no vertical components before collision. It only has horizontal components. Let's answer the questions we are asked to express. In the x direction, this will give us mva cos 60 plus mvb cos 30. That is for the horizontal direction. In the y direction, we have mva sine 60 minus mvb Sine 30. Calculate the magnitudes of the velocities VA and VB after the collision. Let's start with the vertical components. Remember, for the initial momentum, there is no vertical component. So we can use that as 0 equal to mVA sine 60 minus mVB sine 30. Why is it sine 30 and minus is because it is on the fourth quadrant. Let's rearrange it. We have mVA sine 60 equal to mVB sine 30. Since they are the same masses, we take it out. We make VA the subject of the formula, and that gives us VB sine 30 divided by sine 60. Putting that in our calculator, we have it as 0.577 VB. This is where most students get stuck, how they are going to do this combination. Let's go to the horizontal components. MUA plus MUB equal to MVA cos 60 plus MVB cos 30. Because our second object didn't move stationary, so we take that out. Let's cancel out the masses since they are the same masses, so we can focus on the remaining. 500 equal to VA cos 60 plus VB cos 30. But our VA is 0.577 VB. 500 equal to 0.577 VB cos 60 plus VB cos 30. Why we substitute that is for us to find the unknown. This gives us 500 equal to 0.2885 VB plus cos 30 is 0.866 VB. Putting them together, we have 500 equal to 1.154 VB. That will give us VB equal to 500 divided by 1.154, which is 433 meter per second. Remember, our VA is given as VA equal to 0.577 VB. We substitute for VB to have VA equal to 0.577 times 433. This gives us 249.88, in which we can write it as 250 meter per second. We use this to fill this space that VA equal to 250 while VB equal to 433. This is how to answer this collision question. If you have any question, kindly comment it. If you have any year that you are finding it difficult to answer, drop it in the comment section. During one of my solvings, during one of my videos, I will solve it for you. I'll see you in our next video. Make sure you share this, you subscribe, you let your friends know that you can answer all these questions. There is someone who can be there to support you through. I want to see you doing very well in your Cambridge exams. See you at the top and see you in our next video.